All right, guys, as promised, we're going to start a little introduction to factoring today. So you'll definitely want to take notes and write this down because this is super duper important. So I talked to you a little bit in the last recording about, let's say factoring quadratics, about multiplying these quadratics out to get them back to standard form. So what we're going to do in factoring, and you may remember this one, is we're going to take something that is in standard form and we're going to put it in intercept form. And remember, intercept form looks like this. So this is the point of factoring. This is what we do. And there are many, many useful tools for us to use whenever we factor. It'll give us lots of information about the graph, about the equation, and about the quadratic in general when we get it in factored form, okay? So I'm going to run through some steps with you. We'll do one together, and then I'll run through several examples with you. Feel free to pause after we get through this one, and you try to work it, and then go back as I work it together, or as we work it together. All right, let's just start. Let's do a little how-to here. How to factor. Just like when we were graphing, I will do the steps on one side, and I will follow up with an example on the right side. And it's a good example. Not everything factors, actually. So I wanted to make sure I found one that did. Let's see, we got 12, 14, and 4. All right, so if this is the equation that I'm asked to factor down, remember it's going to factor down and it's going to be in intercept form. So I'm going to have two parentheses here as I get this factored down. So my very first step is I want to factor out any GCF. Now, if you don't remember what a GCF is a greatest common factor. So let me just come off to the side for just a second and talk about that. What does it mean to be a greatest common factor? So greatest common factor means that it's the biggest number, or biggest, I don't even want to say number because it could include a variable. Let's say the biggest term, maybe, that goes into terminal value, that goes into everything evenly. So for example, if I had 32 and 16, okay, I would start by listing all the factors, and you won't do this every time because you'll pick it up, but if I'm just learning how to do GCF, the factors of 32 are, of course, 1, 2, 3 does not go in, but 4 does. Not 5, not 6, not 7, but 8 does. 9, 10, 11, 12, 13, 14, I think 16 is the next one. And then, of course, 32 itself. So for 16, I'm at 1, 2, 4, and 16. So the biggest one that they have in common that I could divide both of them by when the remainder would be 16. If I threw some variables in there, maybe I said 18x squared and 27x. What's the greatest common factor? Well, what I'd want to do is I'd want to look at the coefficients first and find the GCF there. And the greatest common factor, the biggest thing you can divide both of those coefficients by would be 9. But the GCF of the variables I could actually divide both of them by x evenly, right? So my GCF here for the two terms would be 9x. Now, whenever I start talking about taking them out of something, if I have something like, if this was written this way, 18x squared plus 27x, okay? When you take the GCF out, what you do is you write that GCF on the outside, and then what you're really doing is backwards distributing here, okay? So you're thinking, if I distributed this GCF through, I'd have to come back to this. So instead of multiplying, I'm thinking dividing. So if I put 9x on the outside, what would need to go here in order to make this 18x squared? And I hope you said 2x. And then what would need to go here in order to make this 27x? Well, it's already got the x, so I don't need another one, but I just need the 3. Okay, so that's the most basic form of factoring, and that is factoring out a GCF. It's something that you should have already done, but if not, there's a little review for you, okay? So let's go back over to our example over here, and let's look. Now, everything won't have a GCF, but if it does, it's important that you do this from the beginning, okay? So you go ahead. And GCF is going to be the key to being able to successfully factor, all right? And I know that there are lots of different methods for factoring, but this is what I have found to be the most beneficial for you because it works in every single situation. All right, so as I look at these, I'm going to look, well, they don't all have x's, so I definitely don't have an x GCF. But all of these coefficients are divisible by 2. So what I'm going to do is I'm just going to take a 2 out. And what's left? Well, if I divide the first term by 2, that leaves me with 6x squared. And the second one by 2 would leave me with 7x. And the last one by 2 would, of course, leave me with 2. All right, so that's the easy part. If you don't have a GCF, then you just skip on down to step 2. And here's where it starts getting a little bit tricky. All right, you're going to multiply your ax squared and your c together. So in other words, the first and the last term. So as I look over here, that would be 6x squared and 2. And together, that would give me 12x squared. And now this becomes a puzzle. And here's the puzzle. What multiplies to, in this case, 12x squared? So what you got in the previous step, but adds to your middle term. And I know that this is very wordy, and if you need to pause to copy down, feel free. But I'm going to come back over here. I'm going to go, okay, well, 12x squared, my middle term is 7x, right? So what multiplies to 12x squared but adds to 7x? So let's think of everything that multiplies to 12x squared. We could have 1x and 12x. We could have 3x and 4x. We could have 6x and 2x. And I think that's it. So of all of these, if I put a plus in the middle of that, which one would equal 7x? Right? 3x and 4x, because 3x plus 4x is 7x. So now what I'm going to do, I'm going to rewrite the middle term using my two new values, or my new term that I got here. Okay, so what does that look like? Well, remember here's my original after I took out that GCF. Instead of writing this as 7x, I can write it as 3x plus 4x, and that's the same thing. I said that it equals 7x, and it does, so I'm going to rewrite it. So it's going to become 2 times 6x squared. I'm going to take this 7x and write it as 3x plus 4x plus 2. I hope you see the steps here in the backwards foiling or distributing problem like we did yesterday, because whenever you foiled those out, you'd multiply out, get something that looks like this, and then combine like terms. We're just doing the exact opposite. We're undoing that multiplication right now. All right, once you've done this part, you're downhill from here. I like to call this step slashing. We're going to slash in the middle. This is an easy one because the signs are all the same, but I will tell you, you will need to watch signs if you have any subtraction signs, and I'll show you exactly what we'll do with those in that situation. But what I want to do is take this quadratic, it is still a quadratic in fact, and I'm going to slash it in the middle. Always slash it after the second term and before that middle sign, okay? And the point in slashing it is I am going to now GCF the first half and the second half. Now what do I mean by that? Let me show you. So I have, copy my problem down here so you can see it a little better. This is one of those things that takes me a while to explain it, but if the problems themselves don't take long, it just takes a while to explain from start to finish. So if I look at these first two terms, this first half here, what is the GCF of 6x squared and 3x? I hope you said, well, it's 3x. So if I take a 3x out of both of these terms, I'm left with 2x plus 1. Okay? Always keep this middle sign no matter what it is, and now find the GCF of the last two. So what can I take out of 4x and 2, or what's the GCF of 4x and 2, and that's 2. And it leaves me with 2x plus, anytime the GCF is the same as this value, you just hold the place with a 1, because if I were to distribute that through, I would end up back where I started. Okay? Now the very last step, and this is important because these two terms must match, and if you've done it correctly and pulled the GCF out and have your two terms in the middle correct, then they will always be the same. But what we're going to do now is factor out the binomial. Okay, that binomial that matches, that two-part this one, I'm going to take that out of the equation now and factor it out just like it was its own GCF, okay? Notice this 2 continues to come down. So in other words, what I'm doing is I'm taking the 2x minus 1, or 2x plus 1, excuse me, 2x plus 1, and because it's being multiplied to both of these, I'm going to treat it like a GCF, and I'm going to take it away from both of them, and I'm going to write what's left, and what's left is 3x, that middle sign again, and 2. And so now it's in a cleaner form here. It's more like the intercept form. Now, it's still not exactly intercept form because of my coefficients here, but it is in factored form, in fact, so that I can work with it here. If you FOIL this out or multiply it out or distribute it out, you will find that you come back to 12x squared plus 14x plus 4. Now, in doing this for many years, I know that this is usually the step that confuses students because you don't understand why it's written twice here but only once here. And here's how I want you to think about this. You have 2 times 3x. Let me just rewrite what we had here. And so it can be confusing to pull this whole chunk out right here. So instead, think about it. If this were 2 times 3xy plus 2y, and I asked you what's the GCF here, I hope you would say, well, it's y, of course, right? And if you took that out, so I put a y in front, well, how do you take the factor that y out? Well, it leaves you with 3x plus 2. The only difference here is my y is 2x plus 1. Okay, if that helps you, good. If it doesn't, I'm sorry. Let me know if you have questions or concerns. Let's do a couple more, and then I'll set you loose with some practice. I'm just flipping over to this sheet that well, I guess I should write it on the mirror board for you. X squared plus 6x plus 5. All right, so let's go through our steps. The first thing we're going to do is look for a GCF. And because this one is a leading coefficient of 1 and they don't all have an x, I don't have a GCF here. So I'm going to move on to the next step. I'm going to multiply the first and the last together to give me 5x squared. So now is the puzzle part. What multiplies to 5x squared but yet adds to 6x? So take a minute and try to figure that out on your own. I hope you said it was 1x and 5x. And so I'm going to rewrite this 6x that way. X squared plus, and you don't have to put the 1 in front of there if you just want to because it makes you feel better. You're welcome to. Oops, that's a 5x. And now I need to slash. And I need to GCF the first two and the last two. So the first two, the GCF there is, of course, x. And it leaves me with x plus 1. Keep that middle sign. And the GCF of 5x and 5 is, of course, 5. It leaves me with x plus 1. And now my binomials match exactly. So I'm going to pull that x plus 1 out. And when I take that away from both of them, what's left, it leaves me with x plus 5. Just as a check, quickly, just to show you in case you did not believe me, x times x is x squared. X times 5 is 5x. Plus 1x plus 5 would bring me to x squared plus 6x plus 5, which is exactly where I started. And notice these middle steps. Look at this step and look at this one. These are in a different order, but they're exactly the same because we are undoing that multiplication is what we're doing. So the steps are the same. This is called factor by grouping. And I like it because it does show you how it is the exact opposite of the multiplication. All right, let's do one that's a little bit harder. Let's do some with some subtraction because we haven't done that. All right. So again, I want to multiply, well, I look for the GCF, and this one does not have a GCF. Most of them are not going to have a GCF in the beginning, but it's better for me to show you that in the beginning than it is for you to learn how to do it without. All right, so I'm going to multiply the first and the last terms together. I get negative 12x squared. So now the question is, what multiplies to negative 12x squared, but adds to this time negative 4x? So this is whenever things start getting a little sticky because I've got to multiply to a negative number, right? And the only way to multiply to a negative number is if one of the terms that I'm multiplying are negative. So I'm going to need one negative, one positive. They're going to have to multiply to negative 12, but add to negative 4. So if you don't know, list them all out. List all the factors out in every order that you can, and then the answer will pop out to you when you do it like that. 6 and 2. Remember, one of them has to be negative, right? Because the only way to get a negative when you multiply it is one negative, one positive. And then, of course, 3 and 4. And those are all the factors. So then I look and go, okay, well, which ones add to negative 4x? There we go. So I'm going to rewrite this. And I will tell you, when multiplying to a negative, always try to write your negative term first. When you rewrite your quadratic. So in other words, I'm going to do x squared minus 6x plus 2x. You're not going to get the wrong answer if you don't. It's just a little bit easier to work with if you do this. But either way is fine. All right, we're going to slash GCF of these two would be x, and it leaves me with x minus 6. Middle sign, and then GCF the last half of the problem. So those are both divisible by 2. Leaves me with x minus 6. And then, of course, I take this common binomial out. When it's gone, what is left? And I have x plus 2. All right, let's do another one. Do 2 more with you and I'll be done. Oh, let's do 4x squared minus 36. Now, as you look at this one, you might go, well, wait, this one's different. And this one is different. And the reason this one's different is it's missing that middle term, right? So it's missing that b. But we said if the whole term is missing, it's a 0, right? So you can still do this. Now you can see that it's a quadratic. Let's take the GCF out. GCF here, of course, is 4. It leaves me with x squared plus 0x minus 9. And now multiply the first and the last together. So multiplies to negative 9x squared. Again, I'm multiplying to a negative, but adds to 0. So if you think about this, if I've got to have one positive and one negative, these are super easy because it would have to be the same number to add to 0, right? So these are all going to be perfect square kind of numbers, and this is a special pattern you may remember. If not, we're going to talk about it at a later time, but right now I'm going to show you why grouping always works, even though these are special type quadratics. All right, so I'm going to rewrite 0 as, remember, start with the negative term if you can. Is negative 3x and 3x still 0x? Yes, it is, so we're still good to go. Let's slash it. 4 times, I can take an x out of those two, leaves me with x minus 3, middle sign, and then these last two, I can take a 3 out, leaves me with x minus 3 again. And now if you look, I have a common binomial, right? So there's where I take that out. And what's left, once that's gone, I have an x and a plus 3. You may notice the pattern or recognize the pattern now. I start with x squared minus 9 and ended up with x minus 3x plus 3. That is no coincidence. But again, we'll talk about that a little bit later. All right, one more. 2, negative 14, 12. All right, so again, this one's going to be probably the most difficult one we've done just for the sign issues, but you'll see whenever we get there, but it's still not hard. GCF of the entire thing would be 2, so I can take that out. And if you want to pause this at any point and try to work it yourself, that would be wonderful. So now multiply the first and the last together. I've got 6x squared. And here's where you kind of scratch your head and go, wait a second. I've got to multiply to a positive number, but I have to add to a negative number. How is that going to work? Well, the only way that's going to work, remember, the only way to get a positive is 2 positives or 2 negatives. And since I'm adding them together and they have to add to a negative, these are both going to have to be negative, okay? So what multiplies to positive 6 but adds to negative 7? Negative 6x and negative 1x. So I'm going to rewrite. Now notice, I always told you to write the negative first, but they're both negative. So it doesn't matter which one you write first. And now I'm going to slash. And here's where things are just a little bit different. My GCF of these two would be x, and it leaves me with x minus 6. I still keep this middle number, right? I mean, this middle sign. When I look at x plus 6, the GCF here is just 1, because anytime you don't have a GCF to take out, I'm just going to hold the place with a 1, right? But really what I've taken out is not 1, but negative 1. So what I have to do is I have to change this middle sign. Okay, that's the only difference here. And then it finishes factoring the same way that it did before. So I would put a note somewhere. Anytime the middle sign is minus, change the last sign when you factor. Okay, I'll leave you some practice work. We'll be on this for a little while. This will take us a while to get through because I want to make sure everyone can factor left, right, up, down, and sideways, because it will be the absolute foundation of everything we do from here on out. Okay, if you don't get it all the way just yet, that's okay. You might want to go back and rewatch the video. Go back and follow the examples through and the steps through. I'll also post you a step sheet. I've been working through the examples that were on the back of the step sheet that I have made. If I can do that here. But it lists exactly with an example, the same example that we worked together, and it will walk you through step by step there, and some tips down at the bottom just like before. But I will post that for you so that you will have it if you want it. And I'll also post your homework. Okay, as always, let me know if you have questions, concerns, or comments, or if I can help you in any way. Just text me or email me. Y'all have a wonderful day.